Today I want to talk about the decomposition reaction. Exactly what is decomposition reaction? A chemical reaction in which a compound splits up into two or more elements or other compounds, then the reaction is called decomposition reaction. According to this definition, a compound may split up into two different elements, or a compound may split up into more than two different elements, or a compound is split up into an element and another compound. Maybe it is split up into two or more than two compounds. Whatever it is, but the reactant is only one. Reactant is taken in left hand side and it is only one, and the product is always two or more than two. Such a reaction is called decomposition reaction. Okay, it will be better to have very common example of decomposition reaction which are frequently asked in the examination. They are potassium chlorate. When heated at high temperature, we know that this is one of the method of preparation of oxygen gas in laboratory, and this is the heating method of preparation of oxygen gas. When potassium chlorate is heated at high temperature, it decomposes into potassium chloride and oxygen gas. Oxygen so produced is collected in the gas jar. Now let's write balanced chemical equation of the same. First, formula equation and then balanced chemical equation. KClO3, potassium chlorate. Its molecular formula is KClO3, where valency of potassium is 1, chlorate is 1, equal valency, no exchange. And when it decomposes, then it forms potassium chloride. K for potassium and chloride means Cl. Both of them have one valency, that's why we don't have to exchange the valency. And oxygen, when becomes free, then it becomes diatomic, so we have to write O2. This is correct formula equation. After this we have to balance it. I suggest the student to start balancing an equation from the right hand corner. Here we have 2 oxygen atom, and here we have 3 oxygen atom. Here it is odd number, here it is even number. First we have to convert odd into even. It can be done by taking 2 in front of this potassium. If we take 2, then oxygen becomes 3 2 just 6. Here it is only 2. If we take here 3, then 3 2 just 6. Oxygen is balanced. Now it is the turn of chlorine. Chlorine here 1, here it is 2. So if we take here 2, then chlorine is balanced and potassium becomes 2, and here also we have 2 potassium atom. Now this is balanced chemical equation. Let's take another example. Calcium carbonate. When calcium carbonate is heated at high temperature, then it decomposes into calcium oxide and carbon dioxide. Not only calcium carbonate, any metallic carbonate, whenever heated at high temperature, it decomposes to form metallic oxide and carbon dioxide. Just for example, when zinc carbonate is heated, then it will decompose to zinc oxide and carbon dioxide. In the same way, when magnesium carbonate is heated, it will decompose to magnesium oxide and carbon dioxide. Whatever is the carbonate, I mean to say any metallic carbonate, when decomposes, then normally it forms metallic oxide and carbon dioxide. So let's write the balanced chemical equation of the same. Calcium Ca, carbonate CO3. Both of them have equal valency 2. So we don't have to exchange. Now it gives calcium oxide. Calcium Ca, oxide means O, and both of them have valency 2. So we don't have to exchange. Now another carbon dioxide, we know CO2. Now let's balance the equation. Oxygen 2 here and here 1, 3. Here also 3, carbon 1, calcium 1, calcium 1. That's why this is balanced chemical equation. We don't have to balance it. Okay, let's go to next. Hydrogen peroxide. appears like water, and it is an unstable compound which slowly decomposes into water and oxygen itself. But when manganese dioxide is used, then the rate of decomposition becomes high. And this is one of the methods of preparation of oxygen in laboratory by non-heating method. When hydrogen peroxide decomposes, it forms water and oxygen. We have to write S2O2 for hydrogen peroxide, and water we know S2O, oxygen whenever it becomes free O2. Now let's balance the equation. Oxygen here 2, here 1. It means there are altogether 3 oxygen atoms in right hand side, but in left hand side only 2. That's why we have to convert odd number into even number. Here it is even number, this is odd. That's why if we take here 2, then altogether oxygen becomes 4, and here only 2. That's why if we take 2 in front of S2O2, then oxygen is balanced, and hydrogen also balanced. 2 2 are 4. Okay, now let's go to next. Silver bromide. When this compound is heated, we can understand easily that it decomposes into silver and bromine. So we have to write silver plus bromine. Now how to write balanced chemical equation? Silver Ag, bromide means bromine is combined, Br, and both of them have one valency. That's why we don't have to exchange. And when it decomposes, then it forms silver. Silver is not diatomic. This is a solid metal, and bromine is diatomic. That's why we have to write Br2. We have bromine here 2, here only 1. That's why if we take here 2, then bromine is balanced. Now silver here 1, and here it is 2. That's why if we take 2 in front of this Ag, then this is now balanced chemical equation. Let's go to another one. Ammonium hydroxide. When it decomposes, then it forms ammonia and water. How to write balanced chemical equation? Ammonium hydroxide means ammonium NH4 is combined with hydroxide OH. Ammonium valency 1, hydroxide valency 1, equal valency, no exchange. Now ammonia, we have to remember its molecular formula NH3. And how it is NH3? Because valency of nitrogen 3 is given to hydrogen. Valency of hydrogen is 1. So we don't have to transfer this 1 to nitrogen, because nitrogen itself is 1. And another product is water, S2O. Now let's balance from the right hand corner. Oxygen 1, here oxygen 1, hydrogen 2 plus 3, 5, here also 5, nitrogen 1, nitrogen 1. This is balanced chemical equation. These are very common example of decomposition reaction which are frequently asked in the examination. Sometimes word equation may be given, we have to convert into balanced chemical equation. Sometimes the same reaction can be asked in the form of question: what happens when potassium chlorate is heated at high temperature, or what happens when hydrogen peroxide decomposes, etc., etc. Whatever it is, but now I think we are able to write balanced chemical equation for this decomposition reaction. Okay, we'll meet in next class with another matter.